Sorry, I'm late. So I'll begin with a word of prayer. Heavenly Father, we thank you for this day again, Lord. I thank you for your students. Just pray you'd help us to use this time wisely, just to prepare for the test tomorrow, that you'd help the students to study the right thing and get as much rest as possible, Lord. You know I pray. Amen. Not that rest is probably an issue. This is an afternoon class, but you never know. Let's see here. This one was one of the math battle problems, right? And let's see here. So this, we just make that dv. We make this guy u, right? And then that gives me minus cosine of x sine n minus 1 power of x plus the integral of cosine of x, because that's my v. The minus and minus give me plus, and then I got to get du. Now du is n minus 1 sine to the n minus 2, because I have to take 1 power away, right? And then I got myself a cosine of x dx by the chain rule. Now, so I need to do an algebra step here. So just to write a little bit less, if you don't mind, this times this gives me cosine squared. Right, cosine squared x is 1 minus sine squared x. Right, so this gives me n minus 1 times the integral of sine to the n minus 2 of x dx. All right, and then minus the integral of sine squared x times the sine n minus 2 of x dx. Does this make sense to you guys? Some of you are nodding, some of you are not nodding.
No.
So what did I do?
I'm trying to see what you did.
I took this cosine times cosine, right? It gave me cosine squared. So that cosine squared has two pieces. It's got a 1, right? This 1 here. So 1 times everything else here gives me n minus 1, and then that.
Oh.
So this is by the cosine term. Now, part of the reason you're confused, you should be confused, because what am I forgetting here? So yeah, this is the sine squared x, right? Minus sine squared x. So I get minus sine squared times n minus 1. So I lost my n minus 1, right? So I need to, sorry about that. Let me be less weird. We still have time here. Let me write it out in a way which is more understandable for you guys. Here. This is more writing for me. N minus 1 times cosine squared of x times the sine of n minus 2 of x dx, right? This cosine squared is a 1 minus sine squared, right? So this is minus cosine of x, sine of n minus 1 of x. Plus n minus 1 times the integral sine n minus 2 of x dx, minus, parentheses, n minus 1 integral sine the n of x dx, right? If you don't mind, I'm just going to go ahead and multiply, this guy times that guy gives me this whole power, right? Are we, now is everyone on the same page? I mean, does it make sense? I mean, okay, it's better, yeah. So the reason, yeah. Mm-hmm. On the math, so math battle was, math battle is always supposed to be challenging, and this would be challenging without help. I mean, how do you know to do what? I mean, what's your?
Like, how would you know that the sine and f(x) is
Go ahead.
Just ask us to derive that
So
part.
like we didn't even have like this sign into the -1x.
Oh, right, you have to think of that.
So we just have to.
Like what, I mean, how would you attack it otherwise, right? Like,
Right.
that's a question.
So, okay.
I mean, you guys tried various things, I imagine, but they may or may not have been productive. Yeah.
So like if you were to solve it from like the left side, like how would you?
Oh, I'm not done yet, but so like did you have a question in the back, Brian? The last two. So when I multiply this times that, there's two pieces. There's the one that comes from this times 1 times that, which gives me this. And then the other piece is this times that, which gives me that. But there's an n minus 1 attached to both. Now, the point of this is that the thing we're trying to find a formula for, we can call I, right? This right here is minus parentheses n minus 1 times I, right? So you can do algebra, and you get I plus n minus 1 times I equals to minus cosine of x sine n minus 1 of x plus n minus 1 integral of the sine of n minus 2 of x dx, right? But what happens when we add, what happens here, this simplifies, right? That's really just n times I, right? Because the I and minus I cancel, right? Therefore, the integral sine to the n of x dx is equal to minus cosine of x sine n minus 1 of x over n plus n minus 1 over n integral. And this was problem like 80, which might not have been in your homework, but I had asked you guys a question about Wallace formula, right? And Wallace formula was built over this iterative formula for sine. I've also mentioned that, you know, this is also sometimes a nice way to calculate the integral powers of sine if you don't like the other way that I've showed you. More to your question, though, like why is this a reasonable question? So the reason this is a reasonable question for the math battle is I derived this in class, right? So
I just like want to know like your thought process, like
oh.
between the sign and to the one on the right, like.
Yeah.
There you go.
Well, the question, I mean, how do we define sine to the n, right? It's sine of x to the n power. How do we define the nth power? It's the n minus 1th power times the thing again. You know, so this is the structure of an exponential function. Yeah, power function rather.
So we were, like for the math battle, we were supposed to know what it equaled and then work backwards to prove it. Because like on the math battle, we were just given the left side.
Right, yeah.
Told to get the right. So we were just supposed to already know the right side and then work backwards to prove it.
I had hoped that you'd go through a calculation like this and discover it for yourself and or just look in your notes where it was shown. Because you took notes, because I wrote this on the board and I went through it. In fact, I wrote it about right here. Scribble, scribble, scribble. I worked it out for when we were talking about Wallace formula. We worked through this. This is part of a larger theme, which is for the next math battle, as you're writing notes for the next week or 2, 3. You should be thinking about, I should be trying to record all the information, which would be useful for the next math battle, right? Because this is an important part of learning, is like writing down what's written on the board in class. I know it seems like a antiquated idea, but at least for me, and for many of you, studies have shown that if you write things down, it helps you remember them. So it's not just a question of like being able to access the information somewhere, right? Like you can, yeah, sure, you can look back at my video later, and provided that whoever was taping got it, and that various other technological things align, you can look it up, right? But the point is not that you can look it up. I mean, I know you can look it up. We can all look it up. The question is, do you own the information for yourself, right? And writing notes in class is one very effective way of going in that direction. Maybe it doesn't accomplish the whole thing, but at least it's a step. Now, set aside the experience of class. Like, how would you work this problem? I think you have to try things, right? So the other hint here is that this is just for arbitrary n. So just breaking it up into sine and cosine isn't going to be successful. Right? So like hope of solving this one the same way I'm about to solve this, there's not much hope. Because it's for n, right? So like the best integration by parts is a good tool there because it might relate n to another n and then give you some formula. But I don't know, it's kind of a creative step, really.
It's basically like, so if that were to be like sine squared x, it'd be like just sine x times sine x.
If it was sine squared, then that's a standard problem that we already know how to. Yeah.
If you were to just,
Oh, yes.
Yeah,
Yeah. Oh, yeah, absolutely.
okay.
I gotcha. So like here, yes? So I think, you know, the question is what's your real question, you know? But your question really is just that, right? Yeah. So I'm sorry. I think I'm the one that was like burdening your question with extra baggage. Yeah.
What you're really asking us to do is just like split it up and then just like integrate
Mm-hmm.
backwards.
Right. I mean,
Derive.
on a test, I'd probably include also the statement, use integration by parts to derive a formula for that.
Like, what do you mean by like, what's the difference between, I don't understand how you're deriving like anything there. Like, aren't we just solving it? Why isn't that just like the antiderivative?
Well, I guess to me the difference between derivation and like sometimes you're asked to check an identity is true.
Like
Verifying identity would be different than deriving an identity.
Yeah, because you would just be proving like its statement. But
Yeah.
like, so if you said derive
I
sine to the n of x dx, do you just want us to split it up into something that's solvable and then solve it, or?
mean, to me this is a derivation because
Oh, because there's an x. There's an arbitrary variable.
And we don't have the idea together to check with.
right.
Because it's an arbitrary variable.
I mean, this is an iterative formula for the nth power signs. It's not actually, anyway, let's get to this one. So this is this problem that many of you got wrong. I mean, I put a 2x instead of a theta there, but that shouldn't have stopped you. And it did. So this is standard problem. What we do is we do 1 minus cosine squared theta, sine theta d theta, right? I think I have found at least 2 errors in my solution to quiz 1. Have you found them?
Did you use the wrong identity cosine squared?
One is here, u equals to cosine. So du minus sine d theta, yeah? I've neglected that sign in the solution. My apologies. I mean, there's a 2x here and other things, but so this is the integral of 1 minus u squared minus du, right? I just like to distribute the minus. That's u squared minus 1 du. So that's 1/3 u cubed minus u plus a constant, right? In other words, 1/3 cosine cubed theta minus cosine theta plus a constant. Now your problem was actually integral of sine cubed of 2x, right? So to start with, I mean, there's different ways to do it, but here's one way. You let u equal to 2x, right? So then du is 2 dx. So this is actually sine cubed u times du over 2, right? Solving for dx. And so that, letting u equal to theta, if you don't mind, this would be 1/2 of 1/3 cosine cubed theta minus cosine. Well, let me just get straight to the point, 2x, yeah. But this is disturbing for me, though, because there's at least 2/3 of you who are not comfortable with the integral of sine cubed. I hope something has happened between like the time you took the quiz and now. Like sine cubed should be something you know how to do. Like it shouldn't be mentally taxing to you if I give you a sine cubed integral. You should know what you're going to do. Yep.
Essentially, it is from the 3 to the 8, right? That's it.
You could, but I wasn't aiming for that. Because I'm not trying to tell you that you need to memorize this formula. You can if you want to, right? But what if I say, integrate cosine cubed? What would you do then? Memorize the cosine version? Fine. Then what do you do?
Well, you have the formula for the cosine version of x times the n of x, you just multiply them.
So you just iterate?
Use the reduction one.
I mean, I'm not against you guys using the reduction formula if you want to, but you got to use it correctly. And I did not see evidence of ability to use reduction formula correctly in the quiz I just graded. So, I mean, that may be an event that has happened for all of you between the time we last saw each other and now, but I don't know. Yeah,
Do you do class averages?
doesn't matter. So cosine to the fifth. Let's talk about this one. This is one you should be able to do without an iterative formula, okay? Without the iterative formula, how do you do this? This is the integral of cosine to the fourth theta, cosine theta d theta, right? And then we can take this cosine to the fourth and we change it to 1 minus sine squared theta squared, right? And then, pick a marker that works. This is the integral of 1 minus u squared du. If I let u equal to sine theta, right? Because then du is cosine theta d theta. Then we can do this integral, right? It's just a polynomial in u. Multiply it out. And so there's nothing you need to memorize here except that this is a technique that you should know. And knowing this technique is important because it is related to many other things we have done, right? But yes, if you memorize the reduction formula for cosine, I'm not going to be like, how dare you? I'm just going to be like, that's not the easiest way, in my opinion, not the easiest way to do this problem. I mean, it's so much more mental baggage to carry, yeah.
So, like, other reduction formula, you just talked about, like, bringing that up.
I'm talking about memorizing the analogous formula to the sine to the n. There's a corresponding cosine to the n of x as it relates to cosine to the n minus 2.
Is that the method that you prefer us to just do?
Yes, this is the method I've spent the bulk of time teaching. That is something that came up in an isolated homework problem about Wallace's formula. And I brought it up again on the math battle, mostly to make a point that you should be taking notes. Not you specifically, but the class generally, you know, but yeah.
So that is using Wallace's formula.
No, we use this to derive Wallace's formula. Repeated application of that derived Wallace's formula for us, yeah.
So also to work that problem out, couldn't you do 1/2, 1 plus?
No, don't do that.
I did that though.
Yeah, but no, don't do that. No. So like I saw, okay, it would have worked out for you. It might have worked out for you, but it's not a. So for the sine cubed, where you need to use the half angle formula is something like integral of cosine to the fourth theta d theta, right? So that one we do, 1/2, 1 plus cosine 2 theta, right? You have to square that monstrosity, and that gives us 1/4, 1 plus 2 cosine 2 theta plus cosine squared 2 theta. And then this, again, yeah. So then you can integrate, I mean, the half plus a fourth gives you, it's a half plus a fourth. Wait a minute, is that a half and a fourth? That's actually a integral of 1/4 plus what? 1/8, isn't it? We've got a half and a 1/8. So this is, I think this is what, 3/8? Yeah. So we got 3 theta over 8 plus 1, that's 1/2, but that's a fourth. Sine 2 theta, 1 over 32, sine 4 theta plus a constant.
And that's the best way of working that problem out, right?
It's a way,
It's a way.
yeah.
Well, you can probably substitute a trig identity in.
I mean, if you use the reduction formula, that's another way. I mean, is that easier? Not for me, because I don't have the reduction formula memorized, but the reduction. Anyway, let me stop talking about reduction formulas. It's not really what I want you to do. I'm just not forbidding it, okay? Because other instructors teach that as the primary method. Whereas I teach this as a primary method because I think it helps you get stronger in algebra. Let's see here. I noticed on the partial fractions problem that a lot of you had not taken my advice on how to set up the partial fractions. And it hurt you when you got to the integration. Here's what I mean. If I had something like x plus 3 over x minus 1 times x squared plus 4x plus 5, which is kind of like the problem I had on the quiz, right? Roughly. Then what you want to do is something like this. So by the way, let me try to talk about partial fractions here for a couple minutes. I'll start with this, but I need to get back to the earlier part where I had you set it up but not find it. A lot of you got that wrong. But for probably good reason. I mean, it's understandable. A lot of you had like half right answers. It gave me hope. There's hope for the partial fraction setup. Many of you are getting closer, getting closer. But this here, complete the square, right? This is x plus 2 squared plus 1. So, and here's what I'm saying. Many of you just put bx plus c. But if you put b times x plus 1 plus c, it just makes life so much easier when you get to the next step, namely integration. Right? Because integrating what I wrote there, my second fraction, it's not bad. Integrating bx plus c, that actually requires some thinking, which you may or may not have been successful in the quiz. Let's see, let's work through it. Yeah? So we've got x plus 3, a times x squared plus 4x plus 5, plus x minus 1 times b times x plus 1 plus c. What should we do to figure out a, b, and c? I think the easiest thing to do is plug in x equal to 1, right? That gives me 4 equal to, well, that's 0. Yep.
I thought you had to write it out twice when it's squared. It's like over another fraction, or under another fraction. Like build up to it. Does that make sense? Like it would just be x plus 2 squared once you do like b over, or whatever over x plus 2 and then another fraction over x plus 2 squared.
Yeah, hypothetical. If it was x plus 3 over x minus 1 times x plus 2 squared, like that, suppose that was the problem.
Yeah.
Then I would do, my partial fractions would be this. In that case, but
So why don't we have to do it there?
because this is an irreducible quadratic, it is not a, it's not, you know, it's not x plus 2 squared, it's x plus 2 squared plus 1, which makes it a different algebraic thing than that. These pick up like logs of the absolute value of x plus 2, and 2 times the log of the, well, no, and then the reciprocal function, like 1 over x plus 2. Those are the kinds of things that come from this integration. The kind of things that come from this integration are things like the natural log of this whole thing square rooted, or inverse tangents. So like really different functions come from these two different algebraic cases. Yeah.
Is the expression x plus 2 quantity squared plus 1, should that plus 1 be included like should there be parentheses around that plus 1 too to make it its own quantity? Because that plus 1, doesn't that,
Well,
isn't that kind of,
so I'm trying to just talk about, when I write this here, I mean what's right here. So I don't need parentheses here because it's under the, you know. Now some of you guys do stuff like this to me, and then it leaves me, I don't even know what to do at that point. But so assuming proper use of, you know, fraction bar, yep. Oh, well, thank you. Don't worry, I have more. Yeah. She's taking last week's quiz. She'll take this week's quiz in about 20 minutes. It's funny. Yeah.
plus, does that matter exactly?
Eeny, meeny, miny, mo, catch a tiger by a toe. If he hollers, you.
So in the numerator, how you represented it with p times x plus 1, will that 1 like always represent whichever number's on the bottom?
Oh my goodness, have I done that? That's supposed to be a 2.
Okay.
Good grief. Ay, ay, ay. Yes, you should be confused. That was not helpful. Thank you. This is why we can't have nice things. Let's see here. So 4, if you plug in 1, you get 4 is equal to this stuff, which is 10. A is 4/10, also known as 2/5, right? And then to find B and C, how do we do it? If we plug in x equals to minus 2, that's kind of nice. The reason that's kind of nice is that makes the B go away, right, in the equation. So that gives us just an equation for C. So I didn't notice. One of you helped me find this in office hours. You asked me a question that made me think of this. I had not thought of this before just now. I mean, this is something new I just learned this semester. What do you know? It's here, so 4. I mean, maybe I thought of it sometime before, but it didn't stick, so it doesn't count. Minus 4, minus 8, plus 5. Over here, what we got? Minus 2 minus 1 is minus 3. B times 0, right, plus C. So we can, what does this give us? 1 equals to, we know what A is, right? 2/5. What's that? Oh, that's just 1. Cool. That's just 1. Right, 9 minus 8, 1. And then over here we got minus 3C.
Wait, is that an 8 or a 5? Oh, sorry, I see what you're saying now.
Oh, okay. But 5. So then what? This gives us 3/5 equals to minus 3C, or C equals to? Minus 1/5, yeah. And then how do you find B? We haven't used 0 yet. 0 is always easy, right? X equals to 0, what's that tell us? 3. 5A, right? Minus what? 2B plus C. Now we know A and B, so we can, we know A and C, so we can find B. This tells me 2B is equal to 5A minus 3 minus C, I think. So B is 1/2 of 5A minus 3 minus C, also known as 1/2 of, what was 5A? 2, right? 2 minus 3 plus 1/5, because minus C is plus 1/5. What's that? Minus 1 plus 1/5, minus 4/5. also known as minus 2/5, I guess. So what do we got? The integral of x plus 3 over x minus 1 times x squared plus 4x plus 5 dx is actually what? Integral. We got a is what? 2/5. 1 over x minus 1. Then what? I should have just factored out a fifth, right? So 1/5 times, what was my b? b, minus 2 times x plus 2. I see it was minus 1 over x plus 2 squared plus 1. Here, I'll do one more step. So I can pull the 2/5 out. That's integral dx over x minus 1. And then what I've got is a minus 2/5, the integral of x plus 2 over x plus 2 quantity squared plus 1. We put dx up in the numerator. Minus 1/5, the integral of dx over x plus 2 quantity squared plus 1. Now this is really nice because each one of these can be done with either a u substitution or a pretty straightforward trig substitution. This one, I'd let u equal to x minus 1. Say u sub 1 is x minus 1. The middle one I can do by letting u sub 2 equal to the denominator. Right? If I do that, what's du? du2 is 2 times x plus 2 dx. So that picks up what's in the numerator there, and the 2 outside. The third one, I personally like to let x plus 2 equal to tangent theta. Right? Because then x plus 2 squared plus 1 will be 1 plus tangent squared theta plus 1, also known as secant squared theta. And my dx is secant squared theta d theta, which means that this is actually the integral, so we have 2/5, the integral of du1 over u1, minus 1/5, the integral of du2 over u2. The 2 got absorbed in the du2, right? Minus 1/5, the integral of, well, d theta, because the secant squareds cancel. So 2/5 log of f's value of x minus 1 minus 1/5 the log of the f's value of x plus 2 squared plus 1, and then minus 1/5 theta, which is inverse tangent of x plus 2. You see, if I fold the x plus 2 into the partial fractions, when I get to the point of integrating such an example, it's not hard. I told you guys this, but you didn't listen to me. Or it didn't occur to you on the quiz. I don't know. I understand. I say a lot of things. It's understandable.
What did you just say? I'm sorry.
Funny. I'm not gonna. He wasn't joking. What I was saying was that. That's funny. All right. So what I was trying to say is that many of you, basically on the quiz, just did this. But then when you got to the step of integrating, you're like, ah! Because if you just have that, it's hard to integrate all of that at once. If you separate it off with this x plus 2 piece and the constant piece, well, the x plus 2 piece folds into this u2 substitution, and the c piece goes into like a trig substitution of sorts, an inverse tangent integral. So, yeah. Now, I got you guys, some of you, on the other one. So this earlier one, something like x squared plus 3. Yeah, gotcha. That's here. X minus 1. Here, let's see if I can do it again. X squared. Probably not. You guys are getting smarter. You're wise to my tricks. That's your 3, 3. Plus 2. There we go. Partial fractions for this. So find the partial fractions. Don't actually find it, but don't set up, let's say. All right. How would this go?
Factor out x squared minus 2.
Yeah, see, that's the thing, is this is x minus 1 times x minus 2, right? So these are a package deal, all right? When you do partial fractions, the first step you have to do is make sure you have taken account of any overlapping factors. You guys just wrote it down and like ignored the fact there's x plus 1 and the two different things in the quiz, right? That was, so this would actually have a over x minus 1 plus b over x minus 1 squared, because they're the same, and then plus c over x minus 2. How about if I have 3x plus 7 over x squared minus 9? How would you do partial fractions for this? First thing you got to do. Here, let me make it x to the 4th minus 81. That's more fun. You got to factor, right? X to the 4th minus 81 is x squared minus 9 times x squared plus 9. But what's that? That's x minus 3 times x plus 3 times x squared plus 9. Now, x squared plus 9, that's the end of the road for the reals. That's an irreducible quadratic. I can't further factor that without complex numbers. But x minus 3 and x plus 3, well, there they are. And so you can do it. A over x minus 3. I mean, you can write down the partial fractions at this point, supposing that you've learned it. No danger of getting, I mean, I didn't ask you to integrate here. I just asked you to set up the partial fractions, so that's kind of the end of the story. But, yeah.
3x plus d, right?
Yes, thank you. Yeah, I definitely take off a point there. Or you could put primes on them. I mean, whatever. But, yeah. Cx plus d. I'm sorry. What's wrong with me? Many things. But anyway, yes? No? What does the test cover? Everything. Integration.
Everything from the homework is fair game, right?
I did say that half of the test would be based on, closely related to your homework, yes. And it's much more that it's related to a moderate homework question as opposed to like Wallace formula, right? I don't mean that, oh, I'm going to go look at the hardest homework problems and try to memorize those. That's not what I'm trying to get across, you guys. You should be focusing on the moderate questions. Like, when I say moderate, you have to understand what I mean. To me, this is a moderate homework question, right? This is not a hard homework question. The sine cubed I had of her, that's not a hard integration, right? I mean,
So, like, I guess two questions that, like, are directly related to that. So, like, you think the test is going to be like, so that's like moderate, and I agree,
I think the test is similar length to the quiz.
similar length to the quiz.
Similar length to the quiz.
Similar length, I like
Yeah.
that. Well, I don't know if I like it.
Every once in a while I make the quiz the test, but that mostly depresses me. So I try not to do it.
Like the exact same quiz.
Yeah. On occasion I've done that. It doesn't turn out well. Well, if you guys know it's going to happen, you study it. But if you don't know it's going to happen, yeah, you still study it. Some of you have like a law that you're aiming for 70%. So like you try not to do better than that because you're worried. Like, I'm aiming for 70, so I want to get an 80. I'm speculating. This mostly comes from when I was teaching physics. But anyway, yes.
So, like, with that said,
That was a joke, but yeah, go on, yeah.
so, like, with all that said, you say the test is, like, I get, mostly, like, techniques of integration?
Yes, but we did cover some hyperbolic and
Yeah, that, yeah.
other graphing and things to start trigonometry, right? Forget entities. Like the first two problems in the homework, adding angles, identities, trigonometry refresher, that's possible. Not going to be the bulk of the test, but it might be like 5%, yeah.
And with taking volumes of,
Yeah, volumes are on, they could be on there. Maybe we should work that, yes?
Yeah, we tried the first one.
Was your question that, Josh?
No, I was saying that you've got a couple of example tests on your website. And
Oh,
I
yeah.
was going to ask a question about a different problem.
The example problems on the website, example tests, old example tests are relevant in the sense that I'm a creature of habit, but they may be irrelevant in the sense that sometimes when I've taught this course, we've managed to get improper integrals on the first test. That wouldn't be reasonable for us, right? We haven't talked about integrals to or from infinity yet. Those wouldn't be on the test, And then the other thing is, in past times, I've taught Calculus 1 right before, so we haven't covered hyperbolic stuff in here. It's just been about integration, right? So that kind of skews the discussion as well. So we did do a little bit in Chapter 5. I should test you some on that. Not a lot, but that's something. Mostly what I'm looking for you, to summarize, what do I really want you guys to know about hyperbolic trig? I want you to know the definition of sinh and cosh and how to work things out for them, right? In other words, if I ask you to derive the derivative of inverse hyperbolic tangent, you ought to be able to do that. Or what's the derivative of hyperbolic tangent? You ought to be able to work that out. So, yeah. Problem 1 on the quiz, for example. One of the paths. You guys, the integration by parts, the e to the ax cosine x dx, that did not go well for most of you. You need to work that through again. Because you should end up with 1 over 1 plus a squared there. And I saw a lot of the same wrong answer, which was not that. I saw a lot of 1 over a something. So that problem most of you need to rework carefully. The integration by parts. If you didn't do that, you should do it. This one. So one of the first 5 integration by parts examples I worked in here was this, but with a equal to 1. So the quiz, right? I think problem 1 on the quiz. Some of you didn't work it because you chose the other path.
Problem 7.
Oh, problem 7, I'm sorry.
Are there math questions online, or the answers to the questions online?
No. Oh, and also for the grading, I should mention, for the grading of the homework, you guys might be curious. Some of you got more than 25, right? 25 is required points, right? But I told the grader, I said, grade by completion for most of the problems, see if they did them. And it's worth a quarter a problem because it's 25 points, there's 100 problems, right? So it's that quarter point per problem. I was and then you pick 5 problems and you grade those. And if they did them, you give them a bonus point per problem. So if you did, oh no, think about it, batteries. Uh-oh. This is not good. I may or may not be able to tell you this. Dang it. Somehow oh well. Anyway, there are 5 problems, I wish I could tell you which ones, that he graded. And if you got those right, you got a bonus point. So your max, you could have gotten 30 out of 25. So, and I'll continue doing that. That's my plan. If you do all of them, you should get 25, provided you've actually made a serious attempt, right? And then if you get the 5 that he randomly grades correctly, that will give you 5 more points. So you can earn up to 30 points per 25 points of homework, which means in principle, if you did this on all 4 of them, that would give you 20 points bonus for the course as a whole, which could be significant. How to set up the volume, I'll just drop. I won't do the integral, but I'll set it up for you guys. So I asked you to find the volume of this shape rotated around this guy, right? So this was x squared plus y squared equals to r squared for x greater than or equal to 0. Of course, you know what that is. This is going to give us a sphere of radius r, right? So I think in my solution that I wrote for the quiz, I used the method of shells. let me use the method of washers here, just to give you a contrast, okay? So there's two techniques, shells or washers, right? To use washers, I think about dividing the disk up into a stack of disks. I mean, the sphere up into a stack of disks like this, right? And so the thickness would then be dy, right? And what's the volume? The little bit of volume from this disk would be pi, the radius. What's the radius? Well, the radius would be x, right? So pi x squared dy. Now, I have to do that for what? Minus r less than or equal to y less than or equal to r. That's just like straightforward. If you just think about it, stack of disks from there to there, right? And then the slightly tricky thing is this is really pi times what's x squared? Well, x squared is r squared minus y squared dy, right? And so v is the integral from minus r to r of pi r squared minus, I forgot how easy this was with washers. I did it with shells on your quiz solution, which is way harder in terms of the integration, because it's actually integration by parts if you do the other way. But if you do the method of washers, it actually works out easier like this. So what's that give us? 2 pi times, looks like r cubed minus 1/3 r cubed, also known as 4/3 pi r cubed, a formula that you should probably know at this point. Or you should definitely know it for physics, right? The volume of a sphere, 4/3 pi r cubed. This is something people assume you know. That may or may not be a legitimate assumption. I mean, I certainly didn't know it going into college. At some point I picked it up, like, oh, so people know this. Okay, I should know it too. Conform. No, sorry. But this is how to derive it with washers. With shells, you think about dividing it up into a bunch of cylindrical shells, where dv is 2 pi rh, in that case dx, right? But the r is, well, the r is still x, but the h is y. Well, twice y, actually, which is 2 pi x, rather 4 pi x, the square root of r squared minus x squared dx. And so I have that solution worked out in the, that solution's given in the quiz. Wherever I did this problem, I have that worked out. But as you can see, if you go with shells, you end up with the trig substitution, right? If you go with washers, that's why this is a reasonable calculus 1 question, right? Here at Liberty, we cover volumes in calculus 1. If you didn't do that, you should probably pay special attention to the volume problems in your homework, right? Yeah. You can ask me about them. I will shut up, I know. So tomorrow, we have a test. Do not despair. You all can do better than the quiz. The quiz is always, what's this quiz? It's supposed to be a wake-up call, right? So you have some idea of where you're wrong. You need to focus on those things.